Good morning, good afternoon, good evening, and welcome to another Developer Experience Office Hours here on Red Hat Live Streaming. I am Chris Short, host with the most and showrunner for this great thing we call Red Hat Live Streaming. And I'm joined by two of my favorite technical people here in the world. Dewan Ahmed and Carlos Santana, not with the guitar, with the Kubernetes clusters. Dewan, do you want to tell us what we're talking about today?
Absolutely. So I'm dialed in from the beautiful New Brunswick on a relatively cloudy day. That's why I have multiple lights on. So today we'll be talking about Kubernetes admission controllers. And before I pass into Carlos, I wanted to ask the audience, who's using Kubernetes admission controllers?
Ooh, good question. And there's a slight delay. So maybe Carlos, introduce yourself.
Yes, please.
Folks, let us know if you're using an admission controller. It's a good question.
It's a delay. My name is Carlos Santana. I work at IBM as a cloud architect. Mostly working with clients on DevOps and cloud native, helping them with OpenShift. So I work a lot with OpenShift, helping them get into the cloud, basically. And I also do open source. So I'm a technical lead for Knative. I run the working group for user experience and docs there. So happy to be here.
Yeah, we're happy to have you, Carlos. This isn't your first time on the channel, is it, Carlos?
Live presenting, yes.
Wow. Okay, I can't believe it's taken this long because you've always been around. I feel.
Yeah, in the chat. I'm always in the chat.
You're always watching, and that's cool. Yeah. We appreciate that. But yeah, it's great to have you on for the first time.
And Carlos is actually one of my ex-colleagues at IBM.
Yeah.
Nice.
Used to work together in IBM.
Awesome.
Yeah.
But you're still in IBM. What do you mean? You never left.
I see. That was a trick question. So coming back to the admission controller piece, that was a trick question because by default, I think Kubernetes ships 30 plus admission controllers.
Sounds about right.
The specific controllers will be, so you're using it by default, even if you don't know it. So today, Carlos will be talking about admission webhooks and how he can use these to manage large set of Argo deployments. It's one thing to deploy a single app on a single cluster, but when you have many apps and you're dealing with many cluster, what are the challenges that we're facing? Before that, Carlos, would you be able to give us some idea about what these admission controllers or webhooks are, just from the very general point of view?
Yeah, so let's use the official Kubernetes docs because OpenShift is Kubernetes, right? And Kubernetes is OpenShift. There's actually, I tell people stories about OpenShift that there's things that started in OpenShift and then they were upstream to Kubernetes. And some people are confused saying, oh, that's in Kubernetes, but it was in OpenShift first, right? And then show up in Kubernetes. So they're like siblings. So let me share my screen and go over a little bit about, you see my screen?
Yes.
So we'll go over the admission controllers. And admission controllers, we're going to talk about the dynamic ones. So there's many of them, but there's two specific ones that are very useful. So one of them is the validation that you can see here, validation webhook and the mutation webhook. And I don't know if they have the picture in this, but essentially is when something, and it could be one of the admins or a developer working with OpenShift, it makes a request to the Kube API server, OpenShift API server. It goes through the different lifecycle checks, you can say, like authentication, you can see here, like authentication, authorization, and then comes validation and mutation webhooks. So if you take the validation webhook, is your opportunity, you as a programmer or admin, or this is also very, very used in operators. When you're writing operators, there's a chance the API has registered, you have registered with the API saying, is this allowed or not allowed? Am I allowed to create a namespace? Am I allowed to create a deployment with a image that is from Docker or the Amazon registry, or it must be from Quay? And you can decide, am I going to allow it or not allow it? And then the API server is asking you and asking like all the people that have put validation webhooks. I think that's what I was saying, like using OpenShift. There's already validation webhooks that you can see in there. And if one of them say denied, forget it, you're not getting to allow access. So this is very different from RBAC. If you're familiar with role-based access control, so RBAC, even though maybe you're an admin and you can create a namespace, let's say, a simple example that we use a lot, if let's say you're an administrator of this OpenShift cluster, and for some reason, I'm managing this cluster for a long time, and I want every namespace to have an owner, like a name and an email of someone, because maybe 3 months from now, I wonder if this namespace is still used, right? And we can delete it or not. So who do we ask? Usually by that time, we cannot find who was the person that created this. So maybe I require that namespace has a label, maybe owner and an email, right? Or a name.
I added a link in the chat, Carlos. If you would like to open that link, I think it might be easier. There's the picture, which goes from authorization, authentication.
Yeah. So this is the picture I was looking for. Thank you. We have the other one. Yeah. So if we zoom in into here, it's asking. So validation is here, but I was just saying it first as validation. And basically, validation is like asking, all these webhooks. And webhooks are people think that are like very complex type of things. They're just HTTP requests with post. It's a web API, similar ones that you use in GitHub. When you push something to GitHub, you get called by a webhook. Basically, that's an HTTP post request, and typically they have application JSON. So what I was saying was, if I'm an admin and I want to have in my cluster, like every namespace must have a label with an owner. I can create a policy. I can create my own validation webhook. I create my own code. So I write a little web code that says, if the namespace to be created doesn't have a label, then deny it. I don't want to be allowed. Then mutation webhooks, it could be something mutating the request. So this one is read-only. So you're allowed, not allowed. This one can allow and not allow, but on top of that can mutate that request. So maybe I'm the lazy developers, like, and I own the cluster. So I'm not going to edit every namespace to add my email address as an owner. So maybe I create a mutation webhook, and the mutation webhook gets called saying, do you want the API server ask your webhook saying, and you register like what type of objects do you want to listen. So maybe I only want to listen to namespaces, for example. You don't want to listen to everything. And then you say, I want to listen to namespaces. And if the label owner is not present, maybe I want to add it. So I'm mutating that request. So when you create a namespace, I check that it doesn't have an owner, and I put like the owner is Carlos, because Carlos is the only one using this OpenShift cluster. And I add that label and owner back to the API saying, hey, go ahead and patch. So the programming model is you're going to patch that resource that typically you see in YAML, but it's actually in API world is JSON. You're going to patch it with a JSON patch saying, add the label owner with my name, Carlos, in there, and then let it through. So by the time when it hits, that's why validation is after. So when validation sees that request, it only sees a namespace with the owner. So like, very good. The namespace has an owner. So that's a high level kind of a story of like, how do they work? And before I learned this, I learned about this recently in terms of like the details behind it. I didn't get my head around this. So I don't know for you two, you knew this, or maybe it's useful.
I think I didn't have much idea about this before, and this 5 minutes overview got me the fundamentals. So thank you for that.
Yeah, thank you so much.
And CRDs, I want to add one more thing. It's like the reason that is using operators is for CRDs. So sometimes you install things like the OpenShift serverless, for example, the one I'm familiar with, which is based on Knative, or Tekton. I'm also working with Tekton. And the version of the CRD, let's say from last year, was V1 Alpha 1. But now you install the new version of the operator. So what about if I want to upgrade those resources to V-beta or V1, like in Knative, we're V1, and we want every resource to be in V1. So one thing that you can do is, if you give me a YAML, you do kubectl apply or OC apply with a YAML with a Knative of V1 Alpha 1. When you write operators, you create a CRD conversion mutation webhook saying, I'm going to convert this resource that now has V1 Alpha 1, and I'm going to convert it to V1. So when it's written into etcd, it has V1. So my webhook can expect the resource saying, well, this field, we changed the name from template to something else. Now, this field needs to be specified, so I'm going to specify default value. And the API version, now we can change to V1. So I just upgraded, the operator was helpful enough to upgrade my YAML to that version, and maybe give you back a message, and you collect messages saying, hey, you should like upgrade this YAML that you have in Git to the V1, but we'll try our best to upgrade you on the fly. But that's the usefulness of the CRDs, and this was in Kubernetes years, on OpenShift years, I will say recent, and it's like recent as 2 years, right? So it's very recent, right? Because operators have been along for a long time. Before there was a time there was no CRDs, right? If people remember programming those. But Mutation Webhook is something that you can specify when you're writing your operator, and the operator SDK, the framework, operator framework SDK. When you start working with that framework, it also helps you, with creating these webhooks, like templating that, like the metadata around it. So I just wanted to add the CRD as a annotation there, because a lot of people ask or see them when they install an operator and they check for validation mutation webhook. They suddenly see all these mutation webhooks. They wonder, like, where are they coming from? What are they used for, right? So you as a cluster administrator should be aware about these things, because they can break your cluster, for example. So these validation webhooks can have something around the failure mode. So we can talk about the failure mode. We want to go deeper. The failure mode is like, if let's say the webhook is down, do I deny the request or do I allow it? Right? Because this is a pod running in your cluster. So maybe you're doing maintenance or something, or it cannot be reached, or it times out. So you can do fail. I think we do the failure policy is called. You can fail or you can ignore. If it's ignore here. So the failure policy, you can say, yeah, if I cannot reach that webhook, go ahead and
keep on.
keep it going, right? It's not that important. Maybe it's a dev cluster, right? We're doing testing. And then maybe in production, you configure the YAML saying, nope, that means I want that check. I want to fail if the webhook cannot be reached, right? Because it could be a security validation webhook, things like OPA, Open Policy Agent, Gatekeeper, Kyverno type of, like, they do security policies. They implement validation webhooks that you can configure with configuration like YAML or Wriggle. And those sometimes are policies that do need to be compliant. So in production, that cluster needs to be in compliance. So you don't want to have it like ignore, like, do your best to be in compliant, right? We never heard auditors saying, well, do your best, but if you can't, like, that's okay. You're either in compliance or not compliance. There's no middle ground with that. Any questions from the chat?
No, but we just get a hey from Khalid. So hey, Khalid, nice to have you.
Hey, Khalid. So these are the documentation in the upstream Kubernetes about validation webhooks. So let's see how we can create one. What do you think?
Sounds good. And we have a specific use case here today. So for those of you who are familiar with Argo CD, you probably know that project. For those of you who are not so familiar with Argo CD, I added a link in the chat. So Argo CD is a GitOps continuous delivery tool for Kubernetes. When you're deploying your application to your cluster, you probably want to follow a GitOps model, which basically says you can use Git as the single source of truth. You make changes in Git rather than making direct changes on the cluster, which is very dangerous. You don't do kubectl apply, you don't do scripts. Even worse, you don't do kubectl apply of a bunch of scripts. You rather make changes on Git, and then those gets reflected on the cluster. And the last thing is all the changes you or your team members are making are verifiable and auditable. So that's what Argo CD, which is an open source tool, provides in short. Carlos will explain the specific use case he has when dealing with large volume of Argo CD apps and how admission webhooks can play a role there.
Yep. So let's take a look at a validation webhook. For that, you have to create a YAML file. So if we look at the YAML file specification, this is the one that I talk about read-only validation. So you register your webhook, and these are the things, the rules. The rules are the things like I want to only be concerned with these objects. If your service that you're going to implement your code, basically the web servers that listens for that HTTP post request, it's going to be sitting in the cluster. You need to specify the namespace and the name, so the API server can form the URL HTTPS, the name of the service dot example namespace dot svc, like that service, and it will call you. You can also have the option, instead of putting service in here, and replace this section for URL. So I have a question for you. So if I put a URL, what can I put in that URL? What do you think I can put in that URL? I think it's down here in the specification. So I can put a URL. I can put a URL in that section. So what can I put in there? What do you think I can put there? Do you see here?
Yeah, I mean, it would be the path to whatever pod you want, really, right?
No,
fully qualified. No,
it can be in my webhook example.com. It can be something outside your cluster.
Oh, okay.
So if you convince your friend to install this YAML file that you put at the bottom of this YAML file, right? And you put HTTPS and it goes to carlos.com. I now have access to, be able to modify or validate your request. So I could be modifying your image pod on the fly, and you will never notice because the deployment says that it has one version, and I'm putting my hack version. So this also could be used for malicious use. So that's why you have to be careful about. So the webhook not necessarily needs to live in a pod in that cluster. It could be living on another cluster. It could be like a Knative, a serverless function living in some cloud. And it could be useful, right? Because it could be used by many clusters, or it could be some exposure that you're like calling something outside the cluster that you shouldn't. So that's where like you put things like egress policies, you put things like Istio to make sure that nothing leaves the cluster. You put network policies. Well, for the kube API, network policy will not work, but you will put something in the nodes, right? In the master nodes. So I just wanted to highlight that because that's something that people are not aware, that you can put a URL and that you'll be calling something outside your cluster, and your cluster may be broken and you don't know why. It's because there's somebody else like messing with you, right? So that was interesting one. So fun tip there, right? Always check, and that's why validation and mutation web is a cluster scope resource. So usually an admin is the one that have access, like it's not namespace. So this is an example of a Node.js validation admission controller. I'm going to show a little bit of that example. So it's also good to see a specific example. I took this one from a blog post I saw the other day. And basically this is the YAML file. So I have the webhook, right? So I have a webhook, validation mutation webhook, and I'm going to listen. And you can be very specific of like, what do you want to listen? So in case that you're doing development, maybe you don't want to listen to everything in the cluster, you want to specific. So I put this one like, because I was like experimenting and it was a cluster that my team was using. I put like, maybe I only want to listen to objects that live in a namespace that match the expression CNTK experiment. So this is like telling my team, like, I'm doing an experiment in this namespace. If you want to, use my validation webhook, go ahead and label your namespace with experiment equals CNTK, and then the kubeAPI server will start sending me events from that namespace. So it's very granular of what you can listen on, right? And then what things do I want to listen? I want to listen to pods. So anytime a deployment, or we say deployment, but it's a replica set. Deployment creates a replica set creates a pod. When a pod gets created, so you have things here like when it gets created, deleted, updated, like you can listen to anything. In this case, I'm listening for pods, but it could be config maps. It could be namespaces. It could be any resource in Kubernetes. This is why it's very powerful, right? This is what I found out is like, this is I would say the easiest way to extend Kubernetes, right? Kubernetes giving you a webhook into here.
Yeah.
And then the scope is namespace. So this resource is a namespace scope. And then what I want the kubeAPI to call, right, is this pod with a service sitting in the default namespace. And then I'm going to allow this registry, and the path is /. Notice that the kubeAPI server always calls with HTTPS. So my code needs to have, this is something very cool that I found out about OpenShift, is when you're developing these type of things, either your framework or the person that is installing this, or sometimes even as a bad practice, your same code is creating the certificates, the TLS certificates. So if the API server is calling an HTTPS endpoint and it's sitting inside your cluster, then your program needs to have an HTTPS or SSL certificate. And then the kubeAPI server, which is serving as a client, needs the CA. Who am I going to trust? So as you can see here, I think I saw CA bundle, something CA bundle. Where was it? I think it was, you look for CA bundle, CA bundle. So CA bundle is a base64 encoded certificate CA. And I was like, do I create a shell script? I don't know if I have it here somewhere. A shell script that like looks like this. Like everybody have done OpenSSL, can be familiar with this, right? OpenSSL create a key for the address of like whitelist register default thing, create a CSR, generate the CA. Now I have the CA. Now I have my tele certificate, right? And then you have to give this to security, and we have to rotate them and all that. So the beauty of this, for people that appreciate not doing this, is you go into your webhook and you add this annotation at the top. I don't know if you can see this.
Inject CA.
You say service.beta.openshift.io inject CA bundle. So when you send this to Kubernetes or OpenShift, OpenShift is going to insert in here the CA bundle of the OpenShift CA. There's an operator CA in OpenShift. So I don't have to do that piece for the CA. The other thing is like, how do I get the certificate and the key for my app? And it could be Go, Python, or Node.js, right? And you go into the deployment, and then in the deployment, you say, you create the service of of my deployment is pointing to my service, but for this service, I use a different annotation, use another annotation saying service beta OpenShift serving cert secret name. Basically, I'm telling OpenShift, hey, OpenShift, create me a secret in this namespace with this service is with this name. And in that secret, I should be able to find my server certificate and my key that I'm going to load into my application. Once I found out this, I'm just testing in OpenShift. Like I don't want to deal anymore with OpenSSL. So by doing this, suddenly a secret would show up in my deployment that I can use. So now I can mount it. So if you're familiar with deployments, right, you will have a volume that you can mount. So you will mount it, and then you have a volume mounting search. And in that search folder inside my application, I will see that. And just showing this, and then let's see the code. So this specific webhook, what it does is having in Node.js. So the thing is, this is a webhook. So web is basically creating a web server. You can use Python, Node, Java, Apache, HTTPD, anything that does a web request with Bash, CGI. And basically this is, I'm using Node.js. This is where I'm loading the certificates that are created by OpenShift. And then I'm inspecting the JSON that I get from the API service. So he sends me a review object. I can, so this is the Git Override. I think I was showing the other one. For the Node.js, let me see the server. So this is a little bit more simple one. So this one is basically what I'm doing is I'm going to configure this validation webhook to allowed or not allowed, true or false, very easy. And basically what I'm going to say is I'm listening for pods. And if the pod starts with a certain registry or it doesn't start with a certain registry, I'm not going to allow it. So in this case, this example is around, let me see if I can find it. It should be here. So I'm have an environment variable in my code saying if the image in the pod starts with docker.io or gcr.io, good. If it starts with, I don't know, the hackregistry.com, it's not going to be allowed, right? So this is very useful for air-gapped environments where customers have in air-gapped environments, they have their own registry. Usually they use Quay from Red Hat, right? And load their own registry. And they have it in their like acme.com internal CA. And for security reasons, they don't allow any image to come from anywhere else. So they will mirror images from the web, they will mirror images from the OpenShift marketplace, and they will have that image here, and they can implement a validation webhook with this small amount of code, right? Where I'm checking if it starts with this, do not allow the pod to be created or to be created.
Quick question, Carlos. Would that allowed registry URL be that mirror registry URL then? Because there will be mirroring from whatever allowed registry to that mirror registry. And are they trusting only that mirror registry which they have?
Yeah. So Quay has a feature called syncing or mirror. So I can have a server called Carlos registry, like register.carlos.com. And I have Quay running there inside my VPC in the cloud, public cloud on premise. And I'm fetching all those images, mirroring those images there. And my OpenShift cluster only takes images from there. So that's a very common scenario in enterprise where they want to have, and that's the opportunity to scan images, right? For CVEs constantly. That's another thing that you can do. Not saying that it's very efficient, but it's possible, right? What happens if in this code, I want to take the registry of that, the image URL of that pod, and inside my app, I want to download it, and I want to run Trivy, or I want to run a scanning right there. And if I find something like critical, I say like, nope, the pod will not be allowed to be created. So that's just an example of like, so you can see the code. So if we go to the code, basically these webhooks, what they expect back is a JSON response, and the document goes into the details. This document was written, I forgot his name, but he's from Google. And I told him the other day on Twitter that this is an amazing document. And I went back to the, I'm a geek, I went back to the Git history. I did a Git blame, and I figured out he wrote most of this code. So other people helped, but the first version, he wrote this, and I said, like, he explained this very, very well. So there's a section here called response section, and then it goes over, what is the request and the response of that API. And he goes around like, what information am I getting and what things that I need to reply. So I need to reply with something very simple. It's a JSON object that has a mission review, and then I'm going to allow it or not allow it. But on top of that, I can mutate it. So let's look at the Argo. Any questions so far? You have any questions?
No, you're good. Go ahead.
Yeah.
But feel free to ask questions, folks that are watching. Yeah.
So that was like a way of like, I'm going to deny things, right? I cannot change the pod. But what about if I want to change the pod on the fly? Like, then I will need to create a mutation webhook. So that goes into like the example here that I have that I wrote the other day. It's a mutation webhook that I want to listen to Argo, like a GitOps definition of an application and projects. And I want to listen the same thing, like the namespace that has this experiment. And what I want to do here is listen to them. And the reason I want to listen to them is because I want to run in my code. And the thing that I want to do is because I'm doing development with a large number of Git repositories that have many Argo apps. So I can show a little bit of the diagram that I'm dealing with. So you see my screen?
Yes.
Yeah, we see it.
So we have typically the clusters. This is not like what everybody does, right? Or specific to everybody does, but most likely these are the things that we test. So you can start with a single cluster that has the, let's say, for example, the namespaces, CI/CD, dev, staging, and prod. And then you can go into like, well, I cannot do everything with one cluster. I need two clusters because in enterprise, you start like dividing the resources. In theory, you should be able to have this, right? Multi-tenancy in OpenShift with a big cluster with a lot of worker nodes. In practice, a lot of customers want to have their own cluster for different purposes. So they can have one for production only, or share one, or they only have one for production and the rest. Or they can even go to the extent, if they're a large corporation, they can have multiple ones for production, meaning like active, or multiple regions. And then they have one for staging, dev, and CI/CD. So all these clusters, definitions, everything that gets deployed doesn't get deployed by a human. That's kind of like the practice in the enterprise when you go GitOps only. It's like, we call it like no sneaky person or sneaky SRE is allowed to go and you run OC apply. Everything is in Git. So then we have multiple Git repos. And the reason we have multiple Git repos is we have different teams. In real world, we don't have one only person knowing about everything. We have people that are in charge of managing the cluster infrastructure. So resources like machine sets, machine configs in that cluster, because we don't want to bother the development team, like namespaces, cluster roles, like those are global things that should be done once and maybe managed by we call it the infrastructure team, right? How many machines you run. The development team really don't care about that. Then we have things like services or shared services, like operators. So if you're going to have a shared service, like let's say service mesh, Istio, maybe you want one control plane, and to manage that control plane, the shared services is the team is in charge of that, or Jaeger, or like in IBM, some Cloud Pak for integration, kind of like middleware. You have one instance and it's managed by the services team, and that person are in charge of that. And then you have the rest of the population of apps where they deploy that. So you have different Git repos that you need to manage with Argo CD. So you will have different Argo apps in different Git repos. So for example, I have this example here. So in Argo, you start with a single, let's say you have a very, very simple starting point. And this is the pattern of apps. I think you were saying, asking me before.
Yeah.
You create an Argo app and you put the YAML for that Argo app. And this is kind of the seed, like you have to apply this manually, or you apply this one from Crossplane, Terraform, Ansible, maybe the whatever automation you have for creating a cluster. That automation usually installs Argo using like Red Hat Advanced Cluster Management, or just puts the Argo in the cluster and then say, and for that Argo instance, here's your starting point. So this is called the bootstrap. Then you have layers. So you have an Argo app that defines the Argo apps that are only for services, the Argo app that is for infra, and the Argo app that is for apps. So you're already starting with a parent and child relationship. And then you start with, well, the apps team want to have different environments, the CI, the dev, the stage, and prod. And then maybe they want to have this in the GitOps repo, and they, in their different teams repo, they want to have another Argo app that deals with the folders inside that repo. For example, the deployables. So let me enable the deployables here. And you have the deployables here. So as you can see, it gets, and this I'm just describing one cluster. So I said before that I have the CI/CD, the dev, the staging, the prod 1, prod 2, and a lot of people even have pre-prod 1, pre-prod 2. they come with all the certain names. So you have many apps like this, and you have the infra. Also, the infra will have services, and infra will have their own Argo apps. So this one has like the cluster roles for the different. So the idea is that the clusters will reuse the same GitHub repo. You don't want to have different GitHub repo for different clusters. So if you want to follow the 12-factor, methodology of having like similar environments, if you're using Istio, for example, 1.6, you don't want Istio 1.9 in staging and 1.6 in prod. You want consistency. So the way you have consistency is by reusing the repos. So you have to put these repos in Git. So you create Git Ripples. So this is an example on how many Git repos you will have. Maybe you have the main one that has these Argo apps. Then you have the GitOps repo that has these folders that are shared. They're like libraries. These first two are like libraries that are shared. And then the last one, this one is like for the different teams. They will have their own kind of like namespaces assigned, and they have their own cycle of using like customized for dev, prod, and staging. So it gets a little bit complex with so many Argo apps everywhere. But once you deploy this, it's static to the point that we have Argo projects. So an Argo project is a resource that says these Argo apps are only allowed to deploy from this Git repo. So you put kind of a governance, right? So if the apps team try to create a cluster role that is defined over here, it will say, no, like you're not in infra, you're in apps. So have some type of control of like in the project. So in the Argo project, you can do kind of like a white list, allow list, saying I'm allowing Argo apps associated with this project only to deploy to these namespaces and only to deploy from these Git repos. And the same thing for services, like only from the services library and only these apps. So if you want to make a change, you will be making a change for the whole team across all the clusters. So that's where I came with the idea of creating kind of like, for development purposes, I'm developing this architecture, and it's open source. All this is open source on the project that I work on. It's called the Cloud Native Toolkit. So this, I'm creating patterns and best practices on how to do DevOps with GitOps and how to structure this in a way that can scale at large corporations. So I'm using this as a developer of GitOps. I don't know if that has a role. The person that develops GitOps and DevOps for other teams to use. But the idea is like these things are I'm doing automation, setting them up, but then I want to change, maybe I want to tweak or debug something in one Argo app. For example, this one. So if I change the YAML for here to point to a fork of my repo that I have, like I'm changing something here, Argo will complain saying this Argo app is not allowed to deploy on my fork because it's not in the Argo project. And then I want to change like one thing. I don't want to change the whole thing. So I need to change now. And then the other thing is like, if I try to change this Argo app would revert it because this is the parent. So I need to change this one and this one. And when I change this one, it gets reverted because the definition of this one is controlled by this Argo app. So if I want to do like development on something that is like, is running as desired in development, and I want to make a change just on my fork, it becomes very difficult. Of like Argo wants to like the state of truth to be in Git. So I need to change this. I need to change this. I need to change the Argo app to add my Git repo, change this one, and then change this one on the cluster, and do it every time that I have a new environment, because I bring out clusters like, every day I bring out 3 clusters, tear them down, bringing that up. So what I did.
One quick point, sorry, Carlos, is just emphasizing on the point of this is something, a use case on development, because in production, you want to follow that proper procedure of making Git changes and going the entire route. You wouldn't make direct changes on the cluster. This is something what Carlos is mentioning, that if you have a large set of clusters, you want to check something using your own personal branch or something on a specific cluster on resources. You don't probably have the time or effort of going through the entire change, and it's not even intended. So how you're using webhooks to make change only for your development environment.
Yeah. So I had this grandiose bad idea of creating a mutation webhook and learning how to create one. So I said, what about if I create a mutation webhook that every time one of these Argo apps gets updated, I override it with my fork, the project and the Argo app, to point to my theme so nothing gets reverted. So I created this mutation webhook that I have in these other Git repo that we can share on the chat, called the Git Override, if I can find it here. And this is one I was explaining, that I want to listen to Argo apps and Argo projects, and I want to modify them on the fly. So I write a little bit of, so I made it configurable. So this deployment webhook will load a configMap. So you as a user, let me see how these Argo apps will look like. And maybe let's do this thing of GitHub now. I know people telling me lately about this new feature.
Pressing the dot.
GitHub. Yeah, pressing the dot.
The pressing the dot thing is mind blowing, but yes.
Yeah. So for testing, I have a testing folder here, and I show kind of like the example, what is the problem that I'm trying to fix. So if I have an Argo project that says I am going to only allow Argo apps to deploy from this Git repo. So if I try to create my fork, or you try to create your fork, the Argo project will say like you cannot deploy because you're only allowed to deploy from this Git repo. So this is some people ask me like, what is the usefulness of Argo projects? Like Argo projects are very useful. A lot of people use the default one and then like, well, I got something working, I don't care, but they are very useful. They also tell like, you can only deploy to these namespaces, right? More governance. And then there's a default set of resources you can deploy, but you can add even more. But for this example, is like, I want to override this line of source repo on the fly. And this is the Argo app parent. So this one points to the same repo on this folder called the test child. So this is the parent Argo app that deploys this child app. And I want to override the child app to point to my own fork and even a different in a different branch. So to do that, I made it like configurable, one validation webhook configurable for my team for development purposes. And I told them as part of automation, we deploy this webhook, and you, based on your personal fork, so Carlos, Dwayne, Chris, you will create the config map in your namespace or in the cluster that you have. So all of us have their own cluster, but using the same Git repo.
And a question on this: who can create this config map? Because this config map would allow you to deploy your own personal fork. So would you need admin privilege to create that config map?
So this config map would need to live in the same place where this deployment lives. So you can create this deployment in your namespace. You don't have to have admin to create a deployment and create the config map. What you need admin access is the webhook. Remember, like the webhook is like the admin configuration.
Yeah.
Where it points, it doesn't matter that much. But yeah, the config map. So my team will create this as when they get a new cluster, like each of us, we have so many clusters for testing. Like we deploy a cluster and you're working with your own cluster to do your changes, right? To validate that you make the change, to debug around. And then you have that I said, like, I don't want to use main, or maybe you're using the same Git repo and you want to use main, you want to use a fork. So I put just fork here. So the config map is basically this upstream URL that maybe is used by Carlos. I want to like change it to my fork, and then the branch to my fork branch. And if I put this Git URL, this config map in there, my code, not my code, but like some little example code will do the checking, saying if it's an application object, I'm going to check for the source and the repo URL. And if I have a match, I'm going to reply back. Remember I said like you give back the API JSON patches. So I'm going to patch the resource, mutate it with saying, no, replace the repo URL with my original URL, the upstream, and replace also the branch. And if it's a project, go ahead and replace it, the repo source URL, right? And replace it with the original one, the origin repo URL. So that way you respond back with this small admission review, but and that's what we talk about validation. So validation only return allowed, and something like this. So this is a mutation webhook. I can also pass a patch type and a patch. So I'm giving back like, hey, mutate the Argo app and the Argo project with my fork URLs, and then send it back. So this code can be written in Python, Java, Go. Typically operators written in Go, they will use the Go client from Kubernetes. So have strong types to the objects that you want to create, the objects of the CRDs. Mm-hmm. But in my case, was a simple like JSON object that I'm not doing anything with CRDs. I'm not doing operators. And I was able to do this and patch the definition that gets into etcd into the cluster. But the problem that you will suffer is what happens if Argo notice that doesn't match the source of truth in the Git repo, doesn't match the one that is in the cluster. What is the typical thing that Argo does? It reconciles. So it says like, no, that's not the source of truth. I want you to be the one in Git.
The app goes out of sync. Yeah,
and it goes out of sync. I was like, so how do I configure Argo to say like, ignore this small amount of fields, right? So basically what you do is you configure Argo. So I have it in the README here as one of the things that you do is you configure the Argo config map. But in case of OpenShift, we have an operator called the OpenShift GitOps operator, and you will configure the instance, that operand of Argo CD, and then you add this to the spec section in there, saying, hey, if it's I'm going to customize and for applications and projects, please ignore these fields in those, like take into account everything, but ignore the things that I'm like changing. And this way, Argo will not try to revert you back to the source of truth. And that's the way we deploy. We apply this to the Argo CD. We create the configMap to your fork, and then we deploy the deployment, which I have in Quay, the image, the YAML file, and then create the webhook. So this piece is the one that you need like admin, because you're going to be affecting your cluster. And then if you want to be affected, like this is with me, like be more paranoid, put a label on it, right? To activate it. That was like the namespace selector type of thing. Any questions, or so far so good?
So far, so good.
I was told that this was going to be a validation admission webhook discussion. So
I think it's an open discussion because it's developer experience office hour, so we're not limited to any particular agenda. It's a free-flowing discussion, especially since we have only 9 minutes remaining. You mentioned about CI/CD best practices with using Argo CD and Tecton. I'm really intrigued to learn more about that, and maybe if we can cover it within 9 minutes, maybe point us to that Cloud Native Toolkit site where our audience could learn more.
Yeah. So one thing that I did, so let's go and cover one more of those two things. The first one is best practices on GitOps on this type of thing. So the version that I had at one point, and the links are going to be in the show notes, is this other one that I have here, the Cloud Native Toolkit. This is a template. So if we do this, let's do the GitHub. I'm getting addicted to this.
Keep pressing out everywhere.
Yeah, the old version until last night, right? I talk about developers like having a deadline. I had this version that was using customized. So I had here, I don't know if this is big enough, but this is the kind of the framework that I'm using. This is the main repo that I was talking about, GitOps. I have like the different profiles where you have like a shared cluster, and each cluster would have their own way of deploying. So I'm using customize to apply the services, or like a customize to apply, like I want Argo, I want Grafana, refactories, the service, Knative, all the things that I want to deploy, just uncomment this, and with customize, I can deploy. The problem that we had was we had so many Argo apps that all of them had this section here, source. So this is kind of the thing that was fixing, right? And the next Argo app has this thing here, and the next Argo app has this thing here. So we wrote a little script to mutate all the Argo apps with the fork that you were doing. And it was kind of like leaving the GitHub dirty. So if you wanted to do a pull request back, it was like all these changes. We also had the project, right? So we had the project in here with these two things, only these two things. So last night I did an update and put it into master with a better option of like actually using customize properly, because I'm learning all this cloud native as we go. So if you use customize properly, I reduce it to this. So now if we take the single cluster, the customization, now I'm using patches in customize. So what I'm doing here is the Argo app, the Argo projects no longer have the GitHub URL. I'm patching, so I'm using a feature in customize called patches with a target. So I'm targeting Argo applications with the label GitOps, and I'm going to add the repo URL and the target revision. I'm going to target app projects, and I'm going to, if they're infra, they get the infra URL. If they're services, they get service URL. And so I'm tagging the resources with the right thing. And for example, if you go now to the instances, there's no source URL. So actually the editor will tell you that you have a bad Argo. But the thing is, I don't want people to continue putting URLs in their Argo apps. Basically, they're going to go into the customization file in here at the bottom, and this is the new section. So now you go to one file to update the Git URL and the branch. So you put your branch in here saying main, and then in here you put https github.com/myfork/gitops this is services, right? This is tagged services. And that's it. It will take all the Argo apps when you run customize from Argo. This is not manually, like Argo supports customize. It would apply this, and then all the Argo apps will have this same information. So you avoid duplication, you avoid error. And there's a little script in here that you run the instructions say to run this, and basically it will take the different, all these 4 repos and put them in the right place for the right Argo apps in the Argo project. So that's the thing that I was telling you, like I have a better way now to do the kind of the Git override with you know, proper customize. And this is kind of the new version of the framework. For Tekton, let's see Tekton and Argo together. So I have an app in here. I have a repo. I have this example running on a cluster. So I have my repos here, and I have this app. So the idea is that I'm going to have different deployments. So if I modify this file, for example, let me do the dot again. Go back to the dot. So let's say the app team, one of the app teams are going to make a change in the Docker file or the application that they have. So this is a customer details app. And I make a change to the Docker file and I save it, say like remove env foobar, and I apply it, and actually it's already applied. So I apply it, I go to Argo, which I have here. Oh no, sorry. I go to the pipeline. So you can see here, I have a Tekton pipeline that kicked off. This pipeline, what it does is builds the image, maybe does Docker links, like things that Tekton are good at. Check your YAML file, do scanning. I remove the ones in the toolkit, we have a long one, but this one is shorter for demo purposes. So it's going to build the image and everything. But the trick is, this is the CI namespace. Nothing runs in here, just Tekton. And the last step, if we see one of the previous rounds, no, if we see the previous runs from, let's see, promote, let me see this one. So I guess this one, let's look at this one. So basically what this does is builds an image, puts it in a registry in case OpenShift. And then the last step, it goes into the repository of the GitOps repo that defines the dev image and updates the image. Then what's happening with that? So if in a GitOps repo gets updated, the repo tells Argo that there's a change. Well, Argo checks every 4 minutes, but then Argo will deploy the new version into dev. So you will see the new version in dev. So if these are all the Argo apps. So if we go to applications and we go to dev and we go here, Argo will deploy the application in dev. And then the next thing that we want to do is running another Tekton pipeline when the application is running in dev. And that Tekton pipeline will do a functional test. We'll run something like Newman. We'll run like integration test. So with the way we do that with Argo is we add a pulse sync job. And that pulse sync job is located here. This job that you see here.
Sorry,
so
Carlos,
job,
I think since we're almost few seconds away from the end line, we can resume probably in a separate session. I think for the audience, we have all the show notes in the chat. And I think most of will be more than happy to invite Carlos over for another session. But I wanted to thank Carlos again for coming to Developer Experience Office Hours. And thanks, Chris, for hosting the show, and for the audience for tuning in.
Yeah, thank you, Chris, and Darren, for the invitation.
Yeah, it's great having you, Carlos, and thank you, Dewan, for bringing them on. Up next is the one and only OpenShift Commons briefing. We'll be talking about cloud-native disaster recovery for stateful workloads. So stay tuned, because this will happen to you. All right, folks, if I don't see you again, stay safe out there, and catch you next time.
Yep.